Okay, ladies and gentlemen, let's finish up with our discussion of variation and rates of change and slope. Now, what we've really been talking about for the entire time, whether we're talking about rates of change, whether we're talking about slope, or we have a new term, variation. All of it boils down to how much change is happening. Now, if something varies, like if times may vary, means things could happen at different times. So variation is how much something differs from something else and how something changes. So again, it's rates of change at slope. We've had this running example where we had y equals 9x, where we made $9 an hour, and we were able to say 0 hours, 1 hour, 2 hours, 3 hours. And we plugged it in 9 times 0, 9 times 1, 9 times 2, 9 times 3, and you end up with 0, 9, 18, 27. And when we graphed that, we put it all on a graph, and we had 0, 1, 2, 3, and we had 5, 10, 15, 20, 25, 30. Okay, so we have 0, we have 9, we have 18, we have 27, and it made a nice pretty straight line. That's an example of direct variation. Now, by direct variation, we mean as one thing does something, the other thing automatically does something else. So, for example, you work 1 hour, automatically you're going to get paid $9 for that hour. If you work 2 hours, automatically you're going to get paid another $9, making 18. 3 hours, 3 times 9, 27. It's a nice, pretty straight line. But direct variation is not always the only type of variation. We have this idea of inverse variation. Okay, and that's going to be, instead of y equals something times x, it's going to be y equals something divided by x. And I want you to think about a pot of gold. Okay, pot of gold, since we have March coming up. And what I want you to do is, for every question that you get right, you get to move half the distance to the pot. So, for example, you have a guy here. You get a question right. If you ask the leprechaun, you get to move half the distance. But then when you get the next question right, you get to move half the distance. The more questions you get right, the distance begins to decrease. The problem is, as the distance decreases, you'll notice the first guy got to move quite a bit, because that was half the distance to the pot. But when you got the second question right, you got to go halfway, but halfway wasn't as far. In the same way, if this guy gets his question right, he gets to move only half the distance. And so on and so forth. You're only going to keep moving half the distance. And if you can only move half the distance, so instead of the first time you move maybe 4 feet, the second time you get to move 2 feet, the next time you only get to move 1 foot, then 6 inches, then 3 inches, then only an inch and a half. The problem is, if you always go half the distance, closer, 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 but you never actually get to go more than half the distance, you never actually make it all the way to the item. This is the idea of inverse variation. As something gets more, something else shrinks. Now, what you'll find is that that graph looks like this. You may have started at 16, but half the distance from 16 was 8. And half that distance was 4. And half that distance was 2. And half that distance was 1. And so on and so forth. But you never actually reach the end. So if we have a graph that looks like this, it's an inverse variation versus a direct variation. Now, let's do an example of an inverse variation. If the number of carpenters needed to frame a house varies inversely to the number of days needed, if 5 carpenters would take 16 days, how many days would it take for 8 carpenters? First of all, it says varies inversely, so we need our formula. Y equals K over X. But it says how many days did it take? 16. For how many carpenters? 5. And so now I need to figure out, well, what is K? In order to move a divide by 5, I need to multiply both sides by 5. I come up with 80 equals K. Now, just like in the direct example, when we did direct variation, our constant was 9. You got $9 every hour. In this case, our constant is 80. And it's a little harder to connect what that means. But it always means that however many days it takes is 80 divided by the number of carpenters. So it's days equals 80 divided by carpenters. In our case, it says how many days would it take if 8 carpenters? So we're going to say days equals 80 over 8. It would take 10 days because you'd reduce, and that'd be 10 days. So with 5 guys, it takes 16 days. With 8 guys, it takes 10 days. Well, if that's the case, 5 guys, 16 days. 8 guys, 10 days. But if I had, say, y equals 80 over, what if I had 10 guys? It's going to take 8 days. And again, we see this shape begin to develop. So, it's very important to understand that inverse variation has this curving, sloping look versus direct variation, which has the straight line look. And hopefully you get an understanding of inverse and direct. Make sure you know those two formulas, y equals kx and y equals k over x. The other type of problem we might want to do with this is we say, if I have a box, I know x and I know y, instead of being given the equation, having to find the y's, let's give you the y's. If I give you this, the question becomes, is it direct or is it inverse? Well, the easiest way is to say, how did I get from here to here? I went up by 350. How did I get from here to here? I went up by 350. Here to here, I went up by 350. So in this case, is everything remaining constant? And is it the same amount every time? If it is, it's going to be direct variation. All right. And the other way to check it is, of course, graph it. If this is what your graph looks like, direct variation. Okay.